Let's begin. Today's June 20th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and its 6 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 6 criteria cards. Criteria card 4, 12, 16, 19, 21, and 22. And we're using the purple verification cards. The code above is your way to find more details on today's puzzle by searching this code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And on the bottom row, we've got criteria card D, criteria card E, and criteria card F. Criteria card A looks at that middle digit, the square digit, and compares it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should it be greater than 4? Criteria card B looks at the first and last digit, the triangle and circle, and compares them. Should the triangle value be less than circle? Should they be equal? Or should the triangle value be greater than circle? Criteria card C looks at our 3-digit solution and will let us know something about the ratio of even to odds. So should there be more even than odds, or should there be less even than odds? Criteria card D looks at the first 2 digits, triangle and square, takes their sum and compares that to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E will look at our 3-digit solution and will let us know a little bit about the structure, meaning is there a pair of digits that are repeating, as in the example 131, or alternatively there are no pairs, but there are 2 scenarios. Either all the digits are all different, as in the example 134, or they're all the same, as in the example 222. So it's a single digit repeated 3 times. And finally, criteria card F tells us a little bit about the order of the solution. So should the digits in our solution be ascending, meaning that they are increasing in value, as in the example 135? Are they descending, or basically getting smaller, as in the example 421? Or do they have no order, meaning that it could be something similar to 231? Now, why does that have no order? Well, if you notice, it first starts off at 2, increases to 3, and then it decreases and goes down to 1. So this change in the values from increasing to decreasing is one example of why it's defined as having no order. And remember, we're looking for a unique 3-digit code, and it's only that one single code that abides by all the 6 criteria cards that we discussed. So we're going to start off with our initial proposal of 314, and the first thing I want to test is I want to know a little bit about the ratio of even to odds. So I'm going to test criteria card C. Okay, so the Turing machine responds that it does not agree with my proposal of 314. Notice that I do have 2 odds to a single even. The Turing machine does not approve of that. So that means that in fact there should be more even than odds. So that's what I'm going to write down in my notes in section C, that even should be greater than odd. So potentially we're looking at least a minimum of 2 evens, but it could be that all 3 are even. Okay, so because we do have at least 2 evens, I'm going to test criteria card D and see if we have a pair or not. So let's go ahead and test criteria card E. Okay, so the Turing machine approves of my proposal. Notice that I do have 314. All the digits are actually different. There are no pairs, and it agrees with that. So that's what I'll write down in my notes for section E, that we have no pair. Okay, so since there is no pair, they're all distinct, but we do have more even than odds. Well, we know that any of the, whether it's a 2 or 4, it cannot be paired up. They're all different. So we can't have a pair of 2s or a pair of 4s, so that means we have to have a 2 and a 4, and then a random odd value. So we know that our solution should have a 2, a 4, and an odd in some order. We still don't know anything about where the evens and odds go. So, but because again they have to be distinct, no pair. Well, I guess I didn't consider whether it could be a single even repeated 3 times. I'm thinking that because if I did have a single digit repeated 3 times, that would mean that it would have no order, right? It's neither increasing nor decreasing, or ascending or descending. And so that would mean that this card would be irrelevant. And the way the puzzle is structured, or the cards are selected for each puzzle, that each card is relevant. You can't just discard it, or it has to bring new information, or it should be able to distinguish potential solutions. And so if it were this single digit repeated 3 times, that would mean it's no order. And so that can't happen. So yeah, so I feel confident that it's going to be a 2, a 4, and an odd. Okay, so that said, I'm left with A and B figuring out what value square might be, or ordering triangle and circle, or having this, finding out a little bit about the sum of triangle and square. Sometimes in puzzles that include this criteria card, it often is equal to 6, and especially since we do have even values, or at least a 2 and a 4, typically it's some order of 2 and 4, but I don't have that yet, and getting an X doesn't really confirm it. So I think I'm going to test criteria card B to get a little bit of a handle of the order of triangle and circle. So let me go ahead and test B. Okay, so it did not approve of the proposal. Notice that I do have triangle 3, circle 4. It did not approve of it, and so we know that triangle can't be less than circle. I think we can even deduce that it can't equal, since they're all distinct. There is no pair, so there's nothing that would be equal. So that means that in fact triangle should then be greater than circle. So let me go ahead and write that down in my notes for B, that triangle should be greater than circle. And I think we'll be able to eliminate something. All right, so if triangle is greater than circle, then I think triangle can't be 1, because if triangle were 1, there's nothing smaller than 1. So it couldn't be, triangle can't be 1. And similarly, circle can't be 5. If 5 is the smallest, well, there's nothing really, anything bigger than 5 that triangle could be. So it looks like we can only eliminate those 2 possibilities. And of course, yeah, we do know that there's a 2, 4, and an odd. Well, that does it for this round. So we've already done our 3 tests. Now we're going into the phase of thinking through how to create a second round proposal. And I'm going to continue on that idea of typically, not always, of course, that especially when you have evens 2 and 4, that sometimes this sum is equal to 6. So that's what I'm going to base my proposal on. But if triangle and square are the 2 and 4, that would mean that circle would have to be forced into an odd value. And so again, I'm hypothesizing that the sum is 6 and that somehow circle would be 1 or 3. So obviously the square value would kind of definitively tell us, well, which one is it? Is it 4 or 2? Again, if it's a 6. And then somehow, with, I guess, what we know about B, and then finally F, that we'd have to be able to deduce that it's either a 1 or a 3. So if it's 2, 4, obviously they're both, well, no, so triangle has to be greater. So if it was 2, 4, it would have to be a 1. Triangle has to be bigger than circle. So 2, 4, 1 would be the only thing. And so because of that, we're not really using this. It defaults it to be that. And I think that's the only possibility, because 2, 4, 3, 2 is not greater. So I don't think it's going to be a 2, 4. I think it's going to be a 4, 2. And so if it's 4, 2, yeah, 4 is both greater than 3 and greater than 1. And so, yeah, so it's going to default to F to tell us whether it's a descending 4, 2, 1 or no order 4, 2, 3. So I think from that perspective, I'm going to test 4, 2, 3, or my proposal of 4, 2, 3. So let's go ahead and do that. So 4, 2, 3, okay, yeah, let's go with it. Okay, so, but before we actually select the criteria cards, is there an order that I could pick them where, you know, I could just do it in less than 6? Meaning, could I somehow deduce one or the other? Well, since I picked 4, yeah, of course it's less than 1 and 3, but that was just B. I guess I could, let's see, if I tested the ordering, would that help? Because if it's 2, well, I still haven't confirmed really whether it's a 6 or not. And that was the whole reason of how I constructed it. So I think it's the prudent thing to do is to test whether that is indeed true or not. Let me go ahead and test D and see if the sum is right. Yeah, okay, so the sum is 6. Now we still don't know the order of it, but at least we know that the sum is 6. So that was criteria D, and yes, the sum of triangle plus square is equal to 6. Okay, and since it is equal to 6, and we do have, again, this 2 and 4, there's no way you could add up an even and an odd to get you 6. That's just not possible. So yeah, so that definitively means that 2 and 4 go in triangle and square. So that means that neither triangle or square can be odd. So I'm going to cross out the 3 and the 5, and then I'm going to cross out 1, 3, 5. Well, yeah, so not 1 or 5, or even 3, 3. And, that would be a pair, which we already know we can't have. And since we do have 2, 4, and they're all distinct, no pair, we do have an odd. So that means that I can actually cross out the evens in circle. So we can't have a 2 or a 4. We do have an odd, which is either 1 or 3. Okay, so that crossed out a whole bunch of digits. Okay, so let's see. I think since we're pretty much have what? 4 different possibilities. Let's see if we were to write them out, could we actually deduce something about them? So we know we could have 2, 4, 1 or 2, 4, 3. 2, 4, 3. And that's it for, 2, 4. Or we could have 4, 2, 1 or 4, 2, 3. Okay. They all have a sum of 6. This has no order because it goes up and then down. Same thing here. This has no order. It goes up and then down. This is descending, 4, 2, 1. And then we have 4, 2, 3, which is also no order. And we haven't tested A or F. Well, if they have no order, we'd ignore this case. And then what does that tell us about A? It would have to be 4, 2, 3 because both of these have the same squares less than 4 value. Again, that's if there's no order. We'd eliminate the descending, and then this would be the only one that's different. What about if it's descending? Well, if it's descending and the sum is 6, wow, is that it? Is it 4, 2, 3? Because if I pick A and say it's 4, well, if I do get 4, it's either descending or no order. But if I pick this and it's less than, they're both no order. Okay, I think that's the trick, that if I pick criteria card A and the value of square is less than 4, these two are the only ones that meet that criteria, but they equally are both no order. 2, 4, 1 and then 2, 4, 3, and there's no way to distinguish them. So yeah, I think we can deduce that the square value is 4, but the only thing we can't deduce is, I guess, the order. Is that right? So somehow I'm saying, let's see, if it's less than 4, we wouldn't be able to tell the order. So yes, I think these would be ambiguous. They're both less than 4. Oh, wait. Oh, I think I'm looking at the wrong thing. I think I reversed it. For some reason, I was looking at triangle, not square, but I think the thinking is still the same. If this is equal to 4, this is equal to 4, square is equal to 4, they both have no order. So they're still being disqualified. I was just looking at the wrong digit, but I think the reasoning is still sound. Yeah, so I don't think it can be. Whoa, can't be these two. So that means we're deducing that the square value is actually less than 4, because it's that middle digit, and then this card is telling us which one it is. Is it descending or is it no order? So I think I can just test F. Okay, so it agrees with, if I look at the proposal, it's 423, that means it has no order, and of course there's my 423. Okay. All right. So it's not 421. Okay, so again here, so this did confirm that there is no order. No order. And up here we are deducing that that square, that middle digit is less than. So let's see. Square is less than 4. I think that's correct. Well, yeah, well, yeah, it's hard to say, but I feel confident. So let's go ahead and make sure. So we're saying that because square is less than 4, that's a deduction, that's a 2. So that means it can't be 4. And then that would mean that triangle has to be the 4, so that the sum is 6. So it's 4, 2. And of course, there's no order, so that means it wouldn't be a 1, because that would be descending. Okay, so yeah, so it looks like 4, 2, 3. And so I think we've already reviewed it. Let's just go to turingmachine.info to verify. So 4, 2, 3. 4, 2, 3. And verify. Okay, yes, for sure. And I think we did do it in lesson 6, so I feel very confident that we got it. So the only thing we didn't test was A. We deduced it. So we did B, C, E, and the first two were wrong, and then D, F, and the second round. So B, C, E. So B, C were wrong, and E was correct. We skipped A, and we were able to deduce A, and we got D and F correct. And so, yeah, so we beat it by 1. Okay, so our ability to list out the last potential solutions, and sort of again using this logic of there is no or there are no irrelevant cards, and finding kind of at least the first two being ambiguous helped us eliminate those, which led us to only have to test F. So our deduction, I think, paid off, and so I think that was great. We were able to do it in 1 less than the Turing Machine, which is always great. Well, if you enjoyed the video, please do give it a thumbs up. If you notice any additional maybe steps I guess I could have taken instead, or how did you solve it? And if yeah, so add that in the comments. And if you did like the video, please give it a thumbs up. And if you don't want to miss out on any future videos, do hit subscribe to be notified. Well, until next time, have a great one.